Hey everyone, welcome back. In this video, I'll take a look at one of these 240 by 320 color LCD displays. These are great little LCD breakout boards that you interact with over SPI. That means that they'll work with any microcontroller or single board computer that supports SPI, which includes Arduino, Raspberry Pi, ESP32, and pretty much any modern microcontroller. They come in all kinds of different form factors. You can see that this one has an optional SD card port on the bottom. Some of them have micro SD ports, some of them don't have any storage options at all. It really just depends on the exact model and where you get them. And then some of them even have touch support. You can see that this one has the pins for it, even though the board doesn't have a touch controller soldered onto it. You can pick them up from just about anywhere that sells hobby electronic parts, like Adafruit, Amazon, eBay, you get the idea. This one came from one of the HackerBoxes that I looked at in a previous video, so I'll go ahead and put a link to that in the description. If you're getting yours from somewhere else, basically you just need to make sure that it uses an ILI9341 LCD controller. The code I'll show in this video should work with any variant of these screens as long as it uses the same controller chip. The first thing I'll do is connect it to an ESP32 board. This one is a DevKit C directly from Espressif. Again, any microcontroller capable of SPI should work. My plan was to do this video with an Arduino, but the one that I have on hand seems to have a corrupt bootloader, so I'll need to try to fix that first. But anyway, I did have this ESP32 on hand as well. You can program these using the Arduino IDE and most of the same libraries, so the code will basically be the same. I'll also show how to use an Espruino Wi-Fi board to control the screen using JavaScript, so stick around for that. You connect to these displays just like any SPI device. If you've never done that before, look up the pinout for your microcontroller and match your SPI pins to the pins on the display, which should be labeled. It's important to mention that this screen takes 3.3 volt logic pins, and some microcontrollers operate at different voltages. 5 volts, for instance, is also pretty common. So you may need to use some resistors or a level converter instead of connecting directly. But if your microcontroller already operates at 3.3 volts, like this ESP32 or this Espruino Wi-Fi, then it's safe to connect directly. In addition to the normal SPI pins, there should also be a pin labeled LED, and you can either connect that to a 3.3 volt output pin or a general purpose digital I/O pin. It's the backlight for the screen, so if you connect it to an I/O pin, you can turn the screen on and off from the microcontroller. This way you can save battery power when it's not in use. There are 3 other pins that aren't typically part of an SPI connection, and those are CS, DC, and reset. You can connect these to any general purpose digital I/O pins, just remember which ones you use because you'll need to reference them in your code. CS is a typical chip select pin, which is how the code will specify which SPI device to write to. DC is sort of like a chip select pin, except it's how the protocol for these screens specifies whether it's sending data or commands. And the reset pin, of course, resets the display. That's all there is to hooking these things up. Now I can jump over to the Arduino IDE and work on the software side of things. The SPI protocol for these screens isn't too bad, and we could definitely write our own library to control them from scratch. But these screens are so common that there's probably already a library written for them for whatever microcontroller you're using. Regardless, I would probably start with an existing implementation just to save some extra work. For Arduino, there's an Adafruit library that seems to work really well, even for these ESP32 boards. You can install it from the library manager in the Arduino IDE, just search for Adafruit ILI9341. And you'll also want to install the Adafruit GFX library, which contains some generic graphics primitives for drawing shapes and text and stuff. Once you've got those libraries installed, you can just include them into a new sketch and then define some constants for the pins. So these are just the pins that I have configured for the ESP32 board. These might be different depending on, which microcontroller you're using. And then you'll use those pin constants to initialize this little TFT object. So this is just using that Adafruit library and creating an object for the screen by passing in all those pin constants. And this is being declared as a global, so we can use it in any functions that we want. In the setup function, I'm setting this TFT LED pin to be an output pin, and then I'm writing high to it. So this is going to turn that backlight for the screen on, and if I ever want to turn it off later, I'll just write low to it. Next, you call the begin method on this TFT object to basically initialize the display, and then I'm setting the rotation here to 1. So you can set the rotation of the screen to different orientations. By default, it starts in portrait mode, and I actually want it to be in landscape mode. So 1 will rotate once, and then if you did 2, it would basically be portrait mode again, but upside down, and then 3 would be the upside down landscape mode. And then finally, this method here fills the screen with a color. In this case, I'm using a constant defined in the library, and the color that this defines is black. But you can use specific colors too, and I'll show you that here in a second. But for now, I'm just going to send this to the screen, and then we'll see what that looks like. So yeah, basically the screen turns on, and then it gets filled with black. Now let's define a specific color here just to make sure that everything's working correctly. So colors for this screen are 16 bits, and the pattern of those bits is 5 red bits, 6 green bits, and then 5 blue bits. So in order to create a specific color, we have to specify a 16-bit integer with our red, green, blue channels filled out correctly in that integer. And the Adafruit library actually has a method that helps with this, and it's called color565. So it takes 3 8-bit integers and then creates that 16-bit color integer. So if I go here and say TFT color 565, then let's say we'll make kind of a pinkish purple color by giving it maximum red and maximum blue, but no green. So then I'll go ahead and save and upload. Cool, and you can see that this time the screen fills with a pinkish purple color. So yeah, interacting with this library is pretty easy. And if we go over here to the source code for the library, specifically the Adafruit GFX header file, we can look at some of the methods that they provide for you to work with. So you see we have methods for drawing vertical lines, horizontal lines, a filled rectangle. So this is interesting. Let's go ahead and draw a rectangle on our screen. I'm just going to copy this method signature so that I don't forget what does what, and then I will make it a method call over here in the Arduino sketch. So we're going to specify the x and y of the rectangle. Let's go ahead and put it at 100, 100. Let's do 100 and then 50 for y. And we'll make it a 20 by 20 rectangle. Let's do 20 by 30. Why not? And for the color, so we've got this pinkish purple background. I don't know, let's make the color yellow. So that's color 565 method. Yellow, of course, is going to be full red and full green channels and no blue. Okay, so now if I save that and then upload again, this time we get a little yellow rectangle on the screen. And that's really all there is to it. Now you can just go through all these different methods and draw different shapes on the screen, and you can create animations and stuff. So let's go ahead and add a circle just to show how that looks. So I'll copy that function signature just so I don't forget. Go tft.drawCircle. So the X and the Y are going to be for the center of the circle. We know that this screen is 320 by 240, so I can do like 160 by 120 for the center of the screen. We'll do a radius of like 30 pixels. And for the color, let's go ahead and make it green. So that's going to be 0, 255, 0. And I'll save and upload. Okay, so you see it drew the outline of the circle. I guess that's not the method that I thought it was. So let's go back here and see what the deal is. Okay, see, I actually wanted this fill circle method. Draw circle apparently just draws the outline. Fill circle should draw a filled in circle. So I'll go ahead and change that. Upload. And there we go. Now I have a yellow rectangle and a green circle. So another useful thing to do with these screens, other than just drawing shapes and making video games and stuff like that, is for displaying text. So text is pretty easy too. You basically just treat this as though it were a serial console or something. You can call this print line method. So let's say, hello world. I'll go ahead and upload it. You can see that the font size is very small. You just barely see it up there in the corner. So there are methods for changing that. And it looks like it's just set text size. There's also a method for setting the cursor position so you can place the text anywhere on the screen. But I'm just going to change the size real quick. So that's tft.setTextSize. Let's go ahead and try size, let's try size 4. So again, we hit upload. And yeah, that's a much larger font. So yeah, this library contains all of the methods that you would need to make your own video game or make a graphical interface for maybe an Internet of Things hub or a thermometer where you want to display the temperature or any other sensors that you connect your microcontroller to. So it's pretty neat stuff. Now I'll jump over to the Espruino board and show how to use JavaScript to control these screens. The code side for Espruino is incredibly easy. There's a standard built-in module that you can include that connects to these screens. Basically, I'm setting up an SPI interface by specifying the pins that I've used and the baud rate, which is the speed for SPI. And then I'm connecting the screen to that SPI interface and then specifying some of those ILI controller specific pins. So then I have this graphics object that's defined by this connection. And this has a clear method, which is going to clear the screen based on whatever the background color is. By default, the background color is black. Then I'm going to set the rotation. This time I'm setting the rotation to 3 instead of 1 because I've got the screen wired upside down, but I still want it to be in landscape mode. So 3 is going to be the upside down landscape mode. And then I'm setting the fill color to be blue. Now the color space on this is 0 through 1 instead of 0 through 255 like in the Arduino example. Just a different way of representing the colors. the Espruino module here handles all the details of that in the background. I feel like it's easier to work with colors in the 0 to 1 range just because a lot of the math is easier. So what I'm doing here is I'm just setting the color to blue and then drawing a filled circle at an X of 100 and a Y of 100 and a radius of 30. And if I send that to the Espruino, you see that it draws a blue circle. So let's do something a little bit more interesting. I'll go down here. I will make a function named loop, which will call itself with like a slight delay. So that's going to be like 1/10 of a second. If you're not familiar with JavaScript, set timeout basically just says I want to call this function after this millisecond delay. So 100 milliseconds is 1/10 of a second. I'm going to copy this. So basically when we call this connect method, we pass all these parameters. One of the parameters we pass is a function, and that's what gets executed after the ILI screen connection is made. So that's why I was doing the graphics code there. So now I'm just going to clear the screen, set the rotation, and then start the loop. So this is going to call loop, and then loop calls itself with a slight delay forever. And in here, I will do a bunch of, well, let's go ahead and say a variable named R, which I'll set to math.random. I will also make green and blue. So this is going to generate a random color. So we've got a random red, green, and blue value. And I'm also going to generate a random X value. And this is going to be a value between 0 and 320. So I'll set that there. And a random Y value, which will be between 0 and 240. I'll set that there. And then R is already defined, so we'll go ahead and call this radius, which will be a random value between, oh, I don't know, 10 and 100. So 10 is the minimum value because I'm adding it to this random, and then, between 0 and 90. So the result will always be between 10 and 100. So then I'll set that to the radius. So if you haven't guessed what this does already, basically it's going to be an infinite loop that just draws a random circle in a random place with a random color. So let's go ahead and hit send and see what it looks like. And I just realized that I made a really stupid mistake by creating a variable named G twice here. Oh, it's an easy fix. I'm going to call this G GFX for graphics, and then replace all of the instances that I used there. So that should work. Now we'll go ahead and send it. And there you go, lots of random circles. So the one thing I will say about these screens, being over SPI, they are limited a bit to speed. For most applications, that's not a big problem, but if you're trying to change a lot of pixels with a high frame rate, you might have a problem with these screens. Usually what you'll do is only change the pixels that have changed over time. So if you're making a game and you have a character who's moving across the screen, you don't redraw the entire screen every frame. You only move the or you only redraw the pixels that have changed, which is going to be, where the character was before and where the character is now. So when you're developing things like that, this speed should be fine. But if you are trying to change every single pixel, every single frame, and you want a high frame rate, these screens might be a problem just because of the limits of, communicating these pixels over SPI. But again, for most purposes, they're great, especially for things like if you're just showing text to show the reading of a sensor or something, this is going to work just fine. Well, that's it for this video. I hope you enjoyed, and go to the comments below. Let me know what you think about these screens. Let me know what you think about this format of videos. I know I haven't been uploading as much recently because I've just been busy with other things, and this is kind of like a hobby side project. I do want to upload more, and feedback from you definitely gives me an idea of, what kind of videos people are interested in. So yeah, if you like this content, hit like and subscribe to my channel, and maybe leave a comment down below. But until next time, bye!